Good morning. I'm audible. Anyone, please unmute yourselves and respond. Unmute yourselves and respond. Am I audible?
Yes, sir.
Okay. In the previous class, we were discussing a few problems on Jacobians. How many problems we discussed? Yes, problems ಆಗಿತ್ತು. At least respond in chat box. Only one. Okay. Okay, fine. Let's start with the second problem. Find the Jacobian of find the Jacobian of u is equal to x into y square, v is equal to y into z square, w is equal to x into z square. Is my writing visible clearly?
Yes, sir.
Okay. Find the Jacobian of u is equal to x into y square, v into y z square, and w is equal to x into z square. Jacobian is denoted by this symbol J, or I can write like this: J of u, v, w divided by x, y, z. Or you can write it as del of u, v, w divided by del of x, y, z. It is given by the determinant whose first row is del u by del x, del u by del y, del u by del z. Second row is del v by del x, del v by del y, and del v by del z. And third row will be del w by del x, del w by del y, del w by del z. This is equal to determinant. Now make the proper substitutions. Del u by del x. Del u by del x means differentiate u partially with respect to x, treating y and z as constants. Therefore, derivative of u partially with respect to x, y square is to be treated as constant. Keep it as it is. Derivative of x with respect to x is 1. Next, del u by del y. Differentiate u partially with respect to y. Here x is to be treated as constant. Keep it as it is, and derivative of y square with respect to y is 2y. Del u by del z. Del u by del z. Differentiate u partially with respect to z, treating x and y as constants. Therefore, both x and y are constants. X, y square is a constant, and derivative of a constant is 0. Next, del v by del x. Differentiate v partially with respect to x, treating y and z as constants. Y is constant, z square is also constant. Therefore, y z square is a constant. Derivative of a constant is 0. Next, del v by del y. Differentiate y into z square partially with respect to y, treating z square as constant. Keep z square as it is. Derivative of y partially with respect to y is 1. Next, del v by del z. Differentiate yz square, treating x and y as constants with respect to z. Therefore, y is to be treated as constant. Keep it as it is. Derivative of z square is 2z. Now, third row. You tell me the derivatives. Del w by del x.
Z square.
Z square, right. Del w by del y.
0.
0.
0.
Yes, there is no y here. Therefore, both x and z are constants. Next, del w by del z.
2xz.
2xz.
2
Yes,
exact.
2xz. 2x into z. That's right. Now let's expand this determinant. Therefore, J is equal to, Jacobian is equal to, I prefer to expand along first row using alternate positive, negative, and positive sign, right? Use positive, negative, and positive sign plus y square into y square into. Leave the column which contains this y square and row which contains this y square. We get a 2 cross 2 determinant like this. If you leave this column and this row, we get z square, 2yz, 0 to xz. First left top to right bottom. Z square into 2xz is 2xz cube. 2xz cube. It's Saridia. 2x. Yes, that's right. Del w by del x into z square. Del w by del y 0. Del w by del z. That's right. Y square into left top to right bottom is z square into 2xz minus 0 into anything is 0. Next, minus 2xy into this negative sign into minus 2xy into. Now leave the column which contains this 2xy and row which contains this 2xy. We get a 2 cross 2 determinant like this. That is 0 to yz, z square to xz. We leave this column, 2xy column and 2xy row. We get 0 to yz, z square to x. Left top to right bottom. 0 into anything is 0 minus 2yz into z square is 2y z cube. 2y z cube. What will be the next term? Plus 0 into anything is 0. You need not write it. This is equal to 2x y square z cube. Minus into minus plus 4x y square z cube. Therefore, this is equal to 2 plus 4, 6x y square z cube. You make a note of this. Six x y square z cube. Next problem. Find the Jacobian of Find the Jacobian of u is equal to x cos y cos z, x cos y cos z, v is equal to x cos y sin z, x cos y sin z, and w is equal to x into sin y. W is equal to x into sin y. This is a problem from the question paper August 2020. Question paper problem. Find the Jacobian of u is equal to x cos y cos z, v is equal to x cos y sin z, and w is equal to x into sin y. Now j is equal to, first write the definition. This is del u by del x, del u by del y, del u by del z. Second row will be del v by del x, del v by del y, del v by del z. And third row will be del w by del x, del w by del y, del w by del z. This is equal to the determinant. Now make these substitutions. Del u by del x. What is del u by del x? Differentiate u partially with respect to x, treating y and z constants. What's the derivative?
Cos y cos z.
Cos y cos z, right? Cos y cos z. Next, del u by del y. X is constant, cos z is constant. What is the derivative?
Minus x cos z
minus
sin.
x sin y
Minus x sin y cos z.
cos z.
Yes. X is to be treated as constant. Cos z is a constant. Keep these two as it is. Derivative of cos y is minus sin y. Next, del u by del z. Del u by del z. Cos z is constant. Sorry, x is constant. Cos y is constant. Differentiate cos z. Derivative will be minus x into
X.
cos y into sin z. Correct? Next, del v by del x. Differentiate this partially with respect to x, treating y and z as constants. What will be the derivative?
Cos y sin z.
Cos y into sin z. Right. Cos y into sin z. Del v by del y. Del v by del y. X
Minus
is
x
constant.
sin y
Sin z.
sin z.
Minus x sin y sin z. Right. Next, del v by del z.
0.
0 now. Del v by del z.
X cos y cos z.
Yes, x cos y cos z. That's right, x cos y cos z. Now del w by del x. Del w by del x.
Sin y.
Sin y, that's right. Sin y. Del w by del y.
X cos y.
X
cos-
cos y. Yes, x cos y. Del w by del z.
0.
0. Yes.
0.
0, right. Now expand this determinant. Therefore, j is equal to, I prefer to expand along first row. using alternate positive, negative, and positive sign. Positive plus cos y into cos z. Cos y into cos z. Now leave this column which contains cos y cos z and row which contains cos y cos z. We get a 2 cross 2 determinant like this. 2 cross 2 determinant. Left top to right bottom. 0 into anything is 0. Minus x cos y into x cos y cos z is x square cos square y cos z. Zero into anything is 0 minus x cos y cos z into x cos y is x square cos square y cos z. Next, minus into minus plus. This negative sign, minus into minus plus x sin y cos z. X sin y cos z into now leave this row which contains x sin y cos z and column which contains x sin y cos z. We get a 2 cross 2 determinant like this. 2 cross 2 determinant. First left top to right bottom. Cos y sin z into 0 is 0 minus x cos y cos z into sin y. X cos y cos z into sin y. Next, plus into minus minus x cos y sin z. X cos y sin z. X cos y sin z. Now leave this column which contains x cos y sin z and column which contains x cos y sin z. We get a 2 cross 2 determinant like this. Left top to right bottom. X cos y sin z into x cos y is this one. Cos y sin z into x cos y is x into cos square y into sin z. X into cos square y into sin z minus right top to left bottom. Minus x sin y sin z into sin y is minus into minus plus x sin square y into sin z. The determinant is expanded. Now open all the brackets. Just open all the brackets. Cos y cos z into minus x square cos square y cos z. That is a minus x square cos y into cos square y is cos cube y. Cos z into cos z is cos square z. Minus x cube cos cube y into cos square z. And here plus into minus minus. X into x is x square. Sin y cos z into cos y cos z sin y. That is sin square y. Sin y into sin y is sin square y. Cos z into cos z is cos square z into this cos y. Next third bracket, minus into plus minus x into x is x square. Cos y into cos square y is cos cube y. Cos y into cos square y is cos cube y. Sin z into sin z is sin square z. Minus into plus minus x cos y sin z into x sin square y sin z. X into x is x square. Cos y into sin square y into sin z into sin z is sin square z. Now simplify this. All the brackets are opened. Just go on simplifying. Therefore, Z is equal to try to simplify this by yourselves. First, consider this term, and this term. First and third term. What is the common factor? What is the common factor? Minus x square into cos cube y, right? Minus x square into cos cube y is common in both the terms. As it comes outside, what we get inside is cos square z plus sin square z, which can be written as 1. Next, remaining two terms. What is the common factor from remaining two terms? In common factor there?
Minus x square sin
Minus-
square y cos y.
Minus x square sin square y cos y. That's right. Sin square y cos y. Then what you get inside the brackets is cos square z plus sin square z. That can be written as 1. This is equal to what is common factor now? From these two terms, what is the common factor? Is minus x square common?
Minus x square cos y.
Yes, minus x square cos y is common in both the terms. As minus x square cos y comes outside, what we get inside is cos square y. And here sin square y. And cos square y plus sin square y is equal to 1. 1 into minus x square cos y is minus x square into cos y. That's the answer. So please make a note of this. If you have any doubts, you can unmute yourselves. Is sore? Is it sore?
Yes, sir.
Okay.
Yes, sir.
Next, find del of UVW. Find del of UVW divided by del of XYZ. How do you read this? Del of UVW divided by del of XYZ is Jacobian of UVW with respect to XYZ. This is just different notation. Where U is equal to x square plus y square plus z square. U is x square plus y square plus z square. And V is xy plus yz plus zx. And W is equal to x plus y plus z. And W is equal to x plus y plus z. And this is a problem from the question paper in January 19 and January 20 also. January 19 and January 20. Now write the Jacobian. Jacobian of UVW with respect to x, y, z. Construct the determinant, whose first row is del u by del x, del u by del y, and del u by del z. Second row is del v by del x, del v by del y, and del v by del z. Third row is del w by del x, del w by del y, del w by del z. Substitute. This is equal to, what are the derivatives? Del u by del x. Differentiate u partially with respect to x.
2x.
To x, right. Del u by del y.
2y.
2y. Del u by del z.
2z.
2z, right. Del v by del x.
Y plus
Y.
Y plus z. Del v by del y.
X plus Z.
X plus z. Del v by del z.
Y plus X.
Y plus x. That's right. Next, del w by del x.
1.
1. Del w by del x.
1.
1.
1.
Del w by del z.
1.
1.
1. That's right. Now expand this determinant. You can expand the determinant or you can use the properties of determinants also. Nimge yavadu convenient to hug ಮಾಡಿ. I prefer to use properties here. What is common factor in first row? 2 is common. You take 2 as common factor. What we get here is x, y, z. Y plus z, x plus z, y plus x. 1, 1, 1. Now take R1 as R1 plus R2. If you do not know properties, you can expand the determinant. In either ways, you can do that. Take R1 as R1 plus R2. Then this is equal to 2 into, what will be the first row now? First row is taken as first plus second. X plus y plus z. Y plus x plus z, that is x plus y plus z. Z plus y plus x, that is x plus y plus z. Second row is not operated, keep it as this y plus z, x plus z, y plus x. Third row is not operated, keep it as this. Therefore, this is equal to 2 into, what is common factor now in first row? X plus y plus z is common in all the three terms, so keep it outside. X plus y plus z. We take it as a common factor, x plus y plus z. As x plus y plus z comes outside, what we get here is, what will be the resultant first row? 1, 1, 1. Because x plus y plus z is kept outside. And here y plus z, x plus z, y plus x. 1, 1, 1. What is the value of this determinant? What is the value of this determinant? Two rows are identical. Therefore, value of this determinant must be 0. 0 into anything is 0. ನಿಮಗೆ ಪ್ರಾಪರ್ಟೀಸ್ ಯೂಸ್ ಮಾಡೋದು ಕಷ್ಟ ಅನ್ಸಿದ್ರೆ ಇಲ್ಲಿಂದ ನೀವು ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಬಹುದು. Make a note of this. Mark your attendance. is 4. Okay. Let's take one more problem. If u is equal to x plus 3y square minus z cube, v is equal to 4x square yz, 4x square yz, and w is equal to 2z square minus xy. Find del of UVW divided by del of xyz. That means Jacobian of UVW with respect to xyz at the specified point 1 minus 1 0. At 1 minus 1 0. This is a problem from the question paper June 2019. June 2019 question paper problem. First write the Jacobian J. J is given by del u by del x, del u by del y, del u by del z, del v by del x, del v by del y, del v by del z, del w by del x, del w by del y, del w by del z. This is the definition of J. Now make these substitutions. Del u by del x,
1.
1. Del u by del y,
6y.
6y.
6y. Next, del u by del z,
3z. Minus
Ma-
3z square.
minus
Minus
3.
3z.
Yes, minus 3z square. Del v by del x,
8yz.
8xyz, 8xyz. Del v by del y,
4x
4x
square z.
4x square.
yes, 4x square z. Del v by del z,
4x square y.
4x square y. That's right. Next, del w by del x,
Minus y.
minus y. Del w by del y,
Minus x.
minus x. Del w by del z,
4z.
4z. That's right. Now J is equal to
4z.
J is required at a point where x is equal to 1, y is equal to minus 1, and z is equal to 0. Substitute 1. 6y, y is minus 1, therefore 6y is minus 6. And z is equal to 0, therefore minus 3z square is 0. Z is equal to 0, therefore 8xyz is 0. Z is equal to 0, therefore 4x square z is 0. 4x square into y, x is 1 and y is minus 1. Therefore, this is minus 4. Next, minus y. Y is minus 1. Therefore, minus y is plus 1. Minus x. Minus into x is 1. And z is 0. Therefore, 4z is 0. The rest you can do. You just expand and find the value of this determinant. We are left with only 2 minutes. Do it fast.
20.
20, that's right. This is equal to 20. Yes, Ananya, that's right. 20. I'll give you a problem. You try this one by yourselves at your home. If x is equal to r sin theta cos phi, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. Show that Jacobian of x, y, z with respect to r theta phi is equal to r square into sin theta. Model question paper problem. You try this one. Anyway, I'll solve this in the next class. But you try this one by yourselves at your home.